This session, we're going to take a look at using multiple classes together in a single program, and how methods can allow different objects of different types to interact with each other. We won't actually be covering any new ground. That is, we won't be introducing any new features that we haven't already seen, but we'll be using them in new and more complex ways. In fact, we'll be seeing our first real emergent complexity from everything we've learned so far working together in a single, relatively big program. It's also a good idea to make sure you're aware of the difference between passing by reference and passing by value, and when and why Python does each. We have a video on this, so you may want to go back and review this at any point. Defining multiple classes. As you've probably assumed, we can absolutely define multiple classes in the same Python program, just like how we can define multiple functions or variables. Let's add some more classes to our student example. Say in our model university program, we don't just want students, we also want books and libraries as well. Let's consider writing classes for each. Our books should have a title, an author, and a year of publication. Our library should have a list of books and a set of students who are members. We also want these classes to work together. We should be able to register students at a library, have students check out a book from a library, but only if they are registered. Let's get started. Simplest to define will be the books. We're going to write a simple book class with 3 fields, all of which are going to be passed as arguments in the constructor. See also that we've added some type hints, which we learned about in our further functions session. Let's modify our student class so that they can have a book of their own. For the purposes of this exercise, we'll say that a student can only have 1 book at once. This is as simple as introducing a new field in the class definition. Note that we haven't given it as a constructor parameter, and by default, the property is going to be none. Our newly created student will have no book. We can set objects to be properties of other objects. In fact, classes, once they've been properly defined, can be thought of really just like any other data type, and used in much the same way. See that we've also used type hinting, saying that we want this property to be of type book. We use this syntax to type hint variables. Finally, let's write our library class, starting as usual with the constructor. This time the constructor doesn't take any arguments. Every field is given some default value. That is an empty list for the bookshelf. This is where the books in the library are going to be stored, and an empty set of members for the students who have registered to the library. Adding functionality. First, let's allow students to register at the library. We will do this by adding a method to the library class. This method will take a student object, can you see the type hint in the parameter, and checks to see if they are already a member of the library using the in keyword against the self.members set. If not, they are added to it, otherwise the method returns early. In either case, a brief message is printed out. We could also have implemented the same functionality by writing a method of the student class. Let's see what that might have looked like. See how similar it looks, because it's doing the same thing, just from a different place. We don't need both, just one, but if you do want to include both, it's a good idea to have one just be a call to the other in disguise. This saves you work and also prevents discrepancies between the 2 implementations. Next, we want to populate the library with books. We're going to write this one a little bit different. Rather than making books as a parameter, this method will create a new book based on the parameters given. The actual variable book is local and won't stay in memory outside of this method, but the actual object will persist as it gets added to bookshelf, which is a property of the library. So long as the library object stays in scope, the book will too. Now we're going to add a method to allow a student to borrow a book from a library. Again, there are different ways we could do this. We could have this be a method of the student, a method of the book, a method of the library, or even write it as a global function. Which one we choose depends on which one we think is the right design for our program. We're going to add it as a method of the library. Remember that we're storing books in a list in our library. Instead of passing the book as an object, we'll want to reference it by index number. will start like this. We only want books to be accessible to students who are members of the library. So the first thing we'll do in the method is to check if the student is a member. If not, we print a message and return from the method early. We also want to check that a student doesn't already have a book on loan. For this, we can use an implicit isNotNone check. Any variable, like our book property of the student, will be read as false if it is none. Basically a Boolean check to see if it's empty. Lastly, we want to prevent a student taking out a book that another student already has. We can do this again by using the implicit isNotNone check, only this time we want to know if it is none, so we're going to use the not keyword. Now the actual functionality. We want to remove the book at the given index from the bookshelf, replacing it with none, like an empty space on the shelf if you like. And we want to give that book to the student. Finally, just to be nice, we'll print out a little message. Here's what it all looks like. Feel free to return to this later or pause it as long as you need. We're now going to walk through using the classes we've just defined. Let's say we're writing a completely fresh program that has imported the class definitions we just wrote. Let's get started. The first thing we're going to do is define some objects. We'll go for 4 students and 1 library. We're going to do this by calling the constructors for each class. We're now going to populate our new library object with some books. 3 books would be disappointingly few for a real library, but it will be enough for this example. We should see that the library will not allow books to be borrowed by students before they have registered, but once they have registered, they can borrow up to 1 book at a time. We should also see that no student can borrow a book if they've already taken out one, and no student can borrow a book that has been taken out by someone else. This has been a run-through of how we can get multiple classes to interact with each other, which we've seen by writing our real, first, complex, multi-part program. If this felt like a lot, even if you didn't quite all understand it at once, do not worry. We've come a long way from Hello World, and this material isn't going anywhere. You can review it and take it as your own pace, as long as you need. The complete code for what we wrote in today's session is available. It's a good idea to look through it yourself. Whatever level of understanding you feel you're currently at, go through it, use it, tweak it, even try rewriting it for yourself. We're almost at the end of the programming fundamentals section of this course. We have one last feature of object-oriented programming yet to cover, inheritance, and then you'll have everything you need to begin tackling programming and moving on to machine learning for yourself.